Hello, I am Sharnali and today I will be discussing the topic Caesar Cipher. Now, first of all, let's talk about ciphers. What are ciphers? It is a term which is very abundantly used in cryptography, that is, the science of protecting information by transforming it into a secure format. And this secure format is nothing but some coded format of the plain text. And now this coded format of the plain text is known as ciphertext. And this cipher is the algorithm applied to the plain text in order to get the ciphertext. Now, can you understand anything from the ciphertext without seeing the plain text? No, right? We cannot understand the ciphertext until and unless it has been decrypted. That is, changing the ciphertext to plain text using a key. Now, until and unless we get a key, we'll not be able to decrypt it. And now, if we are not being able to decrypt it, we will not understand its contents. Now, based on the algorithms used to encode the plain text into ciphertext, ciphers are divided into these types. That is Caesar cipher, monoalphabetic cipher, homophonic substitution cipher, polygram substitution cipher, polyalphabetic substitution cipher, Playfair cipher, and Hill cipher. Now, today's discussion, that is Caesar cipher, is a type of ciphers, of course. Now, let's move on to what Caesar cipher actually is. Caesar cipher is the oldest and the easiest of the ciphers. Caesar cipher is also known as Caesar shift because it was used by Julius Caesar in his private correspondence. It's also known as Caesar's code also. Caesar shift cipher, and it is also a type of substitution cipher. It is also called a type of substitution cipher. Why is it called a substitution cipher? Because in this cipher, we are substituting the letters, the alphabets of plain text by some other alphabets. We are replacing it by some other alphabets. As we are substituting the alphabets of the plain text and replacing it by some other alphabets, so we are calling it substitution cipher. And why is it known as shift cipher? Is that in this process we are shifting some integer, either we are adding or subtracting some numbers in order to get the alphabet or in order to get the cipher text. Now, let's move on to the explanation part. Now, let's have a look at this diagram first. Now, let's consider this array, this row, as the plain text alphabets, and this row right here as the ciphertext alphabet. Now, Caesar cipher left shift of 3. What does it mean? Let's consider E. We can consider anything, D, E or F, but let's consider E over here. Now, what does left shift of 3 means? This means that E in the plain text will be encoded as the alphabet 3 places left to E in the ciphertext, cipher alphabets. Now, the 3 places left to E is B. So, anywhere B, E arises in the ciphertext, in the plain text, it would be encoded by B. It would be substituted by B. This is what means by Caesar cipher left shift of 3. This is the shift. Now, let's move on to this picture. Here you can see 2 wheels, outer and the inner one. The outer one starts from A, goes up till Z, 26 alphabets. The inner wheel also starts with A and goes up till Z. Now, let's consider the outer wheel as the plain text alphabets and the inner wheel as the ciphertext alphabets. Now, what are the differences between these two? here we have A starting from here, from H, and here we have A corresponding to T. Now suppose A were here, then we shifted 7 places to A. We have shifted 7 places, right? 1, 2, 3, 4, 5, 6, 7. We have shifted 7 places. So here we can say that Caesar cipher left shift of 7, because anywhere A arises in the plain text, it would be replaced by T, and if anywhere in this plain text H arises, it would be replaced by A. This is how the Caesar cipher works. This is how the Caesar text is encoded by using Caesar cipher. Now let's quickly jump on to the logic part. Now here in this Caesar cipher, we use simple modular arithmetic. That is, either we are adding or we are subtracting it. We are adding the shift or we are subtracting the shift. Now this is the logic behind encryption. Encryption is converting plain text to ciphertext, right? And decryption is the opposite, that is from converting from ciphertext to plain text. Now here EN, that is the encrypted text, equals X. X is the plain text, index of the plain text alphabet. Now let's say we have given A as index 0, B as 1, and up till Z we have given 25. There are 26 alphabets. We are given Z 25 because we started from 0. Now X, suppose we are having A, we choose A. We want to see what A in the plain text corresponds to in the ciphertext. Now we are not going to place A over here, of course, because it is an integer and shift, N is shift, and N we are having integer. Now we cannot add integer value to any letter, right? So what we will do is, here in this letter part, we will place the index of that letter. Suppose we are choosing A, so we will place here 0. 0 plus, suppose we want the shift to be 3. 0 plus 3 is 0. 0 plus 3 is 3, sorry. And this 3 will correspond to which letter? D, right? It will be corresponding to D. A is 0, B is 1, C is 2, and D is 3. So here, encrypted text, that is the ciphertext, will have D in place of A in the plain text. Now why does mod 26 come? What is the role of it? Now suppose I want to know the corresponding Y, that is, what is the letter, cipher letter that would be placed in the ciphertext corresponding to Y in the plain text. Y have 24 as the index. Now here let's place 24. 24 plus again 3, 27. 27 we do not have 27 letters in our alphabet, right? So what does it mean? 27 mod 26. Here 26 comes, mod 26 comes, because we do not have 27 letters. As we do not have 27 letters, then Y will corresponding to nothing, right? No, this does not happen. Here 27 mod 26 is 1. So encrypted text equals to 1. That is what it would be replaced by here, B1. That is, Y in the plain text will be replaced by B in the ciphertext, because index of B is 1, right? The exact same logic applies for decryption also, that is converting the ciphertext to plain text. You can only spot differences between these two logics over here. Here we have minus, here we have plus. It can go vice versa also. Here we can have minus, here we can have plus also. Now let's move on. Now let's take a look at a Java program which implements Caesar cipher. Now here, as usual, we have the package, the class, the public static and here we have the function. Here we have the method. Inside method we have the ciphertext variable. Now what does this method name? The name of this method is encrypt, and it takes text and s as the parameters. Text here is the plain text and s is the shift, and it will return string. Of course it would return string because it would return the ciphertext, which is a string. Now we will run a for loop from 0 to the text length, this text length, plain text length. Now why we are starting from 0? Let's take an example of this string text cryptography. Now C has index 0 over here. We'll start our for loop from 0 and then we would end up till here. That is the length of this word. Now we have made a loop, a for loop, and then the control moves to the if statement over here. Now what is the condition of the if statement over here? We have text.char at. Now the char at method returns the character at the ith index. The character over 0 index. First we will go with 0 because it's a for loop. So first I would be 0. C here has I index as 0. So here it will return character, that is C character it would return, capital C. Is the capital letter C? Is it the capital letter C? Yes, it is the uppercase. So it will come over here. The control will come in the if block and not go to the else block. If it was small c, lowercase c, then it would have come to this else block. But as it is in the uppercase, it will move over here. Now let's see the logic in this if block. Here also we have text.char method. Here also it would return a character. But how can we do mathematical operations on a character? We cannot write. So what we will do is we will convert or typecast this character into an integer. Now we can do these operations. After we do these operations, we are again going to convert, that is typecast it into character, because we cannot simply insert numbers into our ciphertext, right? So we have to convert it into characters and then insert it. Now here we have 65. This is the ASCII value of the uppercase, and here also we have 65, and here we have 97, that is the ASCII value for the lowercase, and these two are exactly same without this 97, and here we have 65. These are the corresponding ASCII values. Now result, that is the ciphertext, equals to ciphertext plus character. Ciphertext plus this character, it would be inserted over here. This is the function. Now what we will return is we will return this ciphertext, right? And this ciphertext is a string. Now this is the method, and now we have the main method. Here we have given the text. Here we have given this shift also. Here are the texts, and here we have declared the variable. And over here we have called the encrypt function, and let's see whether it runs or not. Yes, it is running. The text is cryptography, shift is 5, and this is the cipher. Better the Caesar Cipher text because it was encoded with the help of Caesar Cipher only, and you cannot interpret anything from looking at this code. Can you interpret anything by looking at this code that the text is cryptography without knowing the shift and all? No, right? You are not being able to detect whether the text is cryptography or something else. This is the beauty of cryptography and ciphers. That's it. That's all about ciphers, Caesar cipher, and thank you.